and welcome to Cherry Pie Math. This video is going to talk about decimal patterns, especially in relation to rational versus irrational numbers. Before we get started, you should know how to convert fractions into decimals, so I'll just do some quick ones here. We'll start with 4/5. So if I was to convert 4/5 to a decimal, I'd put the 4 inside, I'd have the 5 outside. I'm going to make these thicker so I can see them better. 5 does not fit into 4, so it fits in there 0 times, and I put like a point there. And then when you have a number, any number, and there's no like leftovers, you can always put as many zeros as you need in the decimal places, because 0 means that nothing's there. So it's kind of just a placeholder. But I can use it, so I can say 5 goes into 48 times. So that was not where I put the 8, just ignore me. So I put the 8 up there, and then I put 40 down here. I subtract them. I have 0 as a remainder. That means I'm done. So 4/5 is equal to 0.8 as a decimal form. They mean exactly the same amount. It just changes what forms, because you can use fractions, decimals, or percentages to represent kind of a part of the whole. If I was to do 5/3, same thing. I do 5, and then I put a 3 on the outside. This time 3 does go into 5. It goes into there once. So I'll do that. So 5 minus 3 is 2. 3 doesn't go into 2 anymore, so I kind of do the same thing. I put a 0 there. 3 goes into 26 times, and so I can do minus 18. And then I do it again, and I have another 2, and kind of same thing. I can only go in there 6 times, and you can kind of see that no matter how many times I do this, I'm always going to have the same scenario. And so this would be 1.666 repeating. And we'll talk a little bit later how I would represent repeating. Okay, so what is a decimal? Why do we have them? Decimals are a way to represent partials, I guess. And kind of like the space between whole numbers or integers. And we can, like I said, you can use fractions for the same purpose. You can use, kind of use percentages for the same purpose. The nice thing about decimals, though, is that they can show you where to put something on the number line, because it's a lot easier to understand, like 0.7 versus 70 over 100, I guess. Just in terms of where to put it on the number line, because it's easier to compare. But that's what a decimal is. A decimal is just kind of a digitized way of representing a fraction. When we have these, we have different places. The weirdest thing about it is that we don't start at digit 1. So like when we have like the number 135, right? This is the hundredths place, this is the 10th place, this is the ones place. And we have that on like the left side of the decimal point, but on the right side, we actually start in the 10th place. So that first digit there is the 10th, and then we have 100th, and after that you kind of keep going from there. Thousandths, and then 10,000ths. And the reason is, like, if I had 0.3, that's the same thing as saying 3/10. But if I had 35, it'd be like 35 over 100, because that kind of tells you what would your denominator be if you were to convert this back into a fraction. So in another video, I've talked about rational numbers, and just a quick review. Rational numbers are just numbers that can be represented as fractions. Because it can be represented by a fraction, there are specific requirements that it would look like as a decimal. So the first case scenario, for 1 and 2 are pretty similar, but the first case is there's no decimal, or that all decimal digits are 0. And that's kind of similar to case number 2. So if it ends, the decimal ends. So like in this case, for example, 4 is a rational number because as a decimal, it would be 0.00000 blah, 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 right? Because you can put 0 as many times as you want. Similarly, 4.2 is a rational number because it ends. And if I was to continue it, it would also be 0, 0, 0. So that's kind of the same thing. So if it ends, like there's all of the extra decimals are going to be zeros, then it has to be a rational number. The third case scenario is that the decimal repeats. And you'll actually see this with quite a few numbers. The biggest ones that you'll probably see in your life are anything that's divisible by 3, and by 7. Those are the biggest ones that will end up repeating. So for example, I'm going to make I just picked 2 fractions, and I'm going to do these 2 on the video. I want you to pick 2 fractions yourself and just like pick any numbers you want, one on top of the other, and then convert that to a decimal. So for example, 1 divided by 4, I would do 1 inside, kind of like how I did at the beginning. 4 doesn't go into 1, so I would start my decimal there and add another 0. 4 goes into 10 twice, and then I still have a remainder of 2, so I add another 0. That goes into 5 times, and now I'm done. I'm done when my remainder is 0. That means there's nothing left to take care of, and that would be my decimal, 0.25. And this is obviously a rational number, not only because we saw it at the beginning as a fraction, but because we see that this decimal ends. Because this decimal ended, it has to be a rational number, even if we just looked at 0.25. Let's look at this one. It's a little bit harder, 51 divided by 13. So if I did that, 13 goes into 51. I actually don't remember. Let me grab my calculator here. 3 times. Okay, and that would be 2 and then a 1. And then we would have to start our decimal after that. So 13 goes into 129 times. So minus 117, that would be 3. Now I'm just going to skip ahead here. Oh, and now look, we have actually the same thing as we had here. And since we're not changing the 13 at all, it's going to end up repeating. So then I can just predict it's going to be 923076, and then it'll repeat again, 923076, blah, 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 blah. And so this is another example of a rational number because that decimal is repeating. To represent that, I would write 3.923076, and then I put a bar on top of all of that to show I'm actually going to be repeating those numbers. I can't rewrite them for infinity. You might also be asked to round it, and you would just say 3.92. But if you wanted to be more exact, it would look like this. And we can tell that it's a rational number because, like I said, it fits scenario 3 where you're repeating the decimal. So if a fraction repeats, you put a bar over the part that repeats. So if you want to convert it back into a fraction, like if you have a decimal and you convert it back to a fraction, you put the digits on the top and you put on the bottom the one place, I guess. The tens, what place it is, I guess. That's probably a better way to do it. The place it's in. And this method really only works if you have a decimal that ends. If you have a decimal that repeats, I'm actually not going to go over it in this video, but you can look up in my other video and see how you would repeat it, how you would do it if it was repeating. So let's say we have 0.125. We want to convert it to a fraction. So I would do 125, those are the digits, and it's in remember this is 10, this is 100, and this is 1,000 place. So I would put it over the 1,000th place, and then you would have to simplify it. So I usually start by looking if it's divisible by 5, and everyone kind of does this a little bit differently. I just like 5 because it's an easy number, and I obviously can see that these are both divisible by 5, so it would be 25 over 200, and then I can divide by 5 again. Remember, you have to do it to the top and the bottom. And these are actually both divisible by 25, so I'm going to do that by 25. So that would be 1, and that would be 8. And that would be my fraction, is 1/8. So it's really simple. You just have to put the digits on top of the place, and then you just simplify it as much as you can. And then when you can't anymore, then that's your fraction. So what about irrational numbers? So let's look at this. Is this a rational number or not? I guess I should have said rational instead of decimal. Pretend it says rational number. It does not repeat. You can kind of see that all of these numbers are just keep changing them. There is no repetition to them. This is an example of an irrational number. It is still something you can put on the number line, but it is not a rational number. There's no way to convert this into a fraction. It's irrational. It still goes on a number line, but there's no fraction. So some things to remember. Decimals only have zeros, or rational decimals, I guess. Rational decimals that have zeros and a repeat. Or I should have done this better. So some things to remember. Decimals that only have zeros and a repeat are rational, whereas decimals that are unique forever are irrational, kind of like pi or the square root of 2, for example. If you want to convert it back into a fraction, you do have to make sure it ends in this video. That's all we really covered. Then you just have to put it over what place it's in, and then you can simplify it back into a fraction. Anyway, I hope that helps you, and good luck.